Assalamualaikum and hi. My name is Kairo Hazra binti Ladarus, student ID 2023 40 18 and 58. Program code AS120 Group 2. Today, I'm going to present about relative atomic mass and relative molecular mass, which is the most easy topic in chemistry. Without wasting time, let's begin with the first slide. Relative atomic mass and relative molecular mass. What is that? So, this is the content of our topic today, which is we have relative atomic mass introduction, then continued with explanations and examples. Besides that, we also have relative molecular mass introductions and also explanation and example. I think both have explanation and examples, right? At the last, we also have conclusion, which is the closer for today's topic. So, let's see. Okay, do you guys know what is atom? So, atom is the smallest particle of a chemical element that can exist. You guys can see the picture below of the slide. That is atom. Atoms have a very small mass and are so difficult to measure. So, the chemists compare an atom to a standard atom. The mass of an atom compared to a standard atom is known as the relative atomic mass. Other than that, relative atomic mass has no units because it is only a comparative value. Science fact: John Dalton was a scientist who tried to determine the relative atomic mass of each element. Interesting. Each element. So many. So, let's hear the story about the discovery of relative atomic mass. Let's go. Hydrogen. Hydrogen is the lightest atom that have been used as the standard atom, in which mass of hydrogen atom was taken as 1 unit. But there is a problem arise, which is the relative mass of most of the elements cannot be determined. Why? Because they cannot combine with hydrogen, and the hydrogen gas is so difficult to handle. After that, in 1815, the oxygen atom became the standard atom. The majority of elements' relative atomic masses can be determined by combining them with oxygen. But then a problem arises again when 3 isotopes of oxygen was discovered. First, the chemists used natural oxygen that contain all 3 isotopes as a standard. Secondly, the physicists used the isotope oxygen-16 as a standard. Long short story, in 1961, International Atomic Standard agreed to use carbon-12 as a standard due to its atomic mass of 12 units and various other reasons. So, what is the reason? Firstly, the carbon-12 is the prevalent carbon isotope, accounting for approximately 98% of all carbon. The mass of 12 units assigned to 1 carbon atom is accurate. Other than that, carbon-12 is a solid element at the room temperature and is commonly used in laboratories due to its stability and ability to combine with many other elements. It is also frequently used as a standard in mass spectrometer. So, that's the end of the story about the discovery of relative atomic mass. So, let's move on to explanations and examples. Okay, the relative atomic mass of an element is determined by comparing the average mass of one atom of that element to half of the mass of a carbon atom on the carbon-12 scale. As you can see, there is the formula how to calculate relative atomic mass. For example, where for lithium is 7, so mass of one lithium atom is 7 times half mass of one atom carbon-12. Example 1. How many atoms of beryllium have the same mass as 2 atoms of silver? And the RAM is given, which is BE is 9 and AG is 108. The solution are by listing the information given from the question. The number of beryllium atoms is unknown, so we can put N. After that, mass times beryllium atom is equal to mass of 2 atoms of silver. So, N times RAM for beryllium equals to 2 RAM of silver. N times 9 equals to 2 times 108. And last, N equal to 2 times 108 divided by 9. And the final answer is 24. This example reminds me of algebra. Example 2. The mass of aluminium is 27 times greater than half the mass of carbon-12 atom. What is the relative atomic mass of aluminium? Solution. RAM of aluminium equal to 27 times half times mass of 1 carbon-12. So the answer is 27. Let's see the other example. As you can see, how many times is the mass of one zinc atom greater than the mass of one helium atom? So the solution is mass of one zinc atom divided by mass of one helium atom equal to relative atomic mass RAM of zinc divided by relative atomic mass RAM of helium, which is 65/4. The final answer will be 16.25 times. Next questions, before we move on to relative molecular mass. If the mass of element C is 4 times greater than the mass of carbon, what is the relative atomic mass of element A? RAM for carbon is given, which is 12. The solution is relative atomic mass element A equal to 4 times by 12, and the answer is 48. I guess that's the end for relative atomic mass topic. Let's move on to the next slide. Relative molecular mass. Molecules are made up of atoms, so the relative molecular mass of a molecule is calculated by adding the relative atomic mass of all the atoms that make up the object. In addition, the relative molecular mass of a substance is defined as the average mass of one molecule of the substance compared to half of the mass of one atom of carbon-12. Here is the formula of relative molecular mass. More information. The relative molecular mass of a substance can be determined by adding the relative atomic masses of the atoms that make up the molecule. This is because molecules consist of multiple atoms. For example, the relative molecular mass of carbon dioxide is 44. This means that the mass of one carbon dioxide molecule is 44 times half the mass of one carbon-12 atom. Here's the example. Calculate the relative molecular mass of water H2O and RMM given which hydrogen equal to 1 and oxygen equal to 16. This you can get from the periodic table. The solution is RMM H2O equal to 2 times 1 plus 16 divided by half times 12, and the final answer is 18. Here is some of the calculation of relative molecular mass of some substance. Science fact: relative atomic mass and relative molecular mass has no units. That's all from me. Thank you for watching. See you in another time. Bye and Assalamualaikum.